4.1. What do you notice? What do you wonder? Go ahead.
Why the line doesn't start at the origin?
Ooh, why doesn't the line start at the origin? Good question. Do you remember from 7th grade, to be a proportional relationship, two things must be true?
It must go through the origin.
And?
Has to be straight line.
Yeah, all the dots have to connect, right? That was good. Doesn't go through the origin. Why doesn't it? Okay, good question. What else? Yeah?
None of the dots are on the line.
None of the dots are on the line. How would you describe those dots?
Not perpendicular.
Yeah, so we're going to make a couple of these today. They're actually called scattered plots. Scattered or scatter plots. Dots are scattered around, so I guess we can just say scatter plots. Other things I notice is I could tell you the slope of that line. Slope is 1.5, and I could actually tell you where that graph is going to cross at 22.7 on the y-axis. So yesterday I sent you a video that, I think it was yesterday, that I said you would need for class on Thursday. So there is somebody that is weighing out some oranges, and you are going to watch that video. It's only like 50 seconds long, and you're going to plot the numbers that you see as they're weighing oranges in your chart, and then I would like you to plot the points on that graph. Okay, so I sent you a Canvas message yesterday. Watch the video. Pause if you needed to jot those numbers down. Don't need the sound on if the orange is going in. Jot the points down. It's a nice chart for you. And put the dots on the graph.
I better get that one over. Are we supposed to do? Is the weight on the video already in kilograms?
Yep. All you gotta do is write it down.
Around it or just?
Write it down.
You said you
Don't need the sound on.
Why?
I don't need to listen to the guy putting oranges in the box.
I do, so I know when it's bigger.
That's why you should do, honestly, like research and not kill.
I think you should do it with me, except pay more attention to detail.
Think too much and not get colors. So are we not learning anything about, what's it called?
Okay.
Like anything with those graphs anymore? Are you
That was so
moving on?
cool.
Just
Those
something else?
oranges look very cheesy.
What did you ask, Georgia? Put your dots on that graph too, please. Do the best you can.
I asked him, are we not doing anything with like these anymore? These graphs?
Well, not currently. All right.
Do we need more items?
As you are finishing that up, hopefully you have a graph that looks similar to mine. Again, when I go to the thousandth place, the dots are going to be a little more varied probably on everybody's graph. But hopefully you can see they don't line up perfectly. There's no one perfect line that will go through every dot. Okay, so we are going to draw something called the line of best fit. That's what number 3 wants you to do at the bottom. So can you draw a line that may or may not go through some points, but it's close to all the dots? It's like an average of all the dots, like they did for the first one that we looked at.
Doesn't have to go through the origin.
Does not have to go through the origin.
We did this in 8th grade, or 7th grade. Or 8th grade.
Okay, so in a perfect world, you should have some above the line, some below. It's just an average. Okay, the line of best fit on our scatter plot. Everybody have that? You can use the side of your iPad to draw a line. You can get a ruler or whatever you need. I use the side of a Post-it note. Okay, so now we're on to number 4. Estimate a value for the slope of the line you drew. What does the value of the slope represent? Okay, so everybody's slope is probably going to be a little different because of where you put the dots. So I'm going to try to find 2 points that are on my line here. Okay, it appears I have 2 points, and it's the value of 8 and 7 that were in my chart. So if you have 2 points that your line goes through, use those, or the ones that are closest. So for mine, it's the point 7 and 8. So this point, remember, was 7 and 1.761. This point is 8 and 2.115, coming from my chart up above. So to get slope, remember, I subtract the y's, 2.115 minus 1.761 over the x's, rise over run. So my slope is about 0.35.
Wait, can you go back to that equation again, please?
And nobody's going to have the same number here, I would guess. Okay, now what does that number represent? 0.35 what in my example? Per? Yeah, so that represents the weight for every orange, approximately. And again, the whole point of this is it does say estimate. So, I mean, you could be probably anywhere from 0.2 to 0.4. Depending on your graph. And we will talk about how to use Desmos to help us with this in the future. Okay, it says estimate the weight of a box containing 11 oranges.
Yeah, but we have Jefferson.
So how can I do that?
You would take your
Just add
slope times 11.
0.35
How many times?
once.
One more time, add a 0.35 to that?
Well, add it to 10, whatever. We take it times 11.
You would take 0.35 plus 2.56.
So if every orange is gonna be approximately 0.35. What was my weight of 10?
2.569.
2.569
9.
plus 0.35. So about 2.91 kilograms. Now, do you think that's gonna be pretty accurate? I mean, you could check on your line if you think that would be close.
I have a question. What if,
Does every orange weigh the same amount?
No.
No. So it's probably an okay guess, probably not gonna be great. Okay, because this was pretty much between orange 7 and 8 on my account. George, you had a question.
yeah, never mind.
Question number 6. I have 50 oranges. Give me an approximate weight.
50 times.
40 times 0.35 plus 2.569. Are we doing everything with our stuff we got, or yours?
Don't matter. If you're doing yours, your numbers are gonna be a little different.
Yeah.
60 or
You would do 40 times your slope.
Why 40? Oh, then you're gonna add it?
Yeah.
Okay. So George just said to take 40 times my 0.35 number. And then I assume you're gonna add it for how much the 10 weigh.
Yeah, 2.569.
So 40 times 0.35,
14.
it's exactly 14. So about 16.59. Now, do you think that one's gonna be more accurate or less compared to number 5? Probably less accurate, more variability. 40 more oranges could vary a lot.
I got 10, not 16.
Question number 7, estimate the coordinates for the vertical intercept of the line we drew, the y-intercept. So I'm going to draw this line to continue. Mine looks to be just shy of 0.5. 0.45 maybe. Good with that? So-
Way of the box, or
So what does that represent?
what? Way of the box.
Y-intercept.
That is the y-intercept, that would be the weight of the box.
Oh.
Zero oranges would still have a weight of 0.45, that is the weight of the cardboard box. Which points are the best fit by our model? Well,
The ones that are right on the
the
line.
ones that are on the line, so 7 oranges and 8 in my drawing. Again, this could be varying to yours. Which point or points are least fit well? Look the worse.
5.
Yeah, mine are 4 and 10. Whatever yours are. 10 is definitely worse on mine. And I'll put far away from line. Make sure you explain. All right, question 3. Here it has a line drawn for us and an equation, which is nice. What is the predicted sale price of an item that has ingredients that cost $1.50? So if we look, X represents our ingredients, Y represents our sales price, our cost. So it says if X is $1.50, you know, I can look at where it meets my line and make a guess. But I'm going to use the formula. I'm going to plug in $1.50 for X. So 3.48 times ingredients that are worth $1.50 plus 0.76. So if you have a calculator handy, which you do, 3.48 times $1.50 plus 0.76.
5.98.
Anybody confirm that?
That's 7.6. Yeah. It's
598. Now we said it'd be really close to 6, right? That's pretty close to 6. Getting more accurate than just looking at our graph. Question number 2, what is the predicted ingredient cost if it has $7? So now this is your Y value. So I'm going to do the exact same thing. And this time I have to figure out X. So how do I solve for X algebraically? Well, I'd have to subtract 0.76. So 7 minus 0.76. And then divide by this number in front of the X. So I would have to take 7 minus 0.76, and whatever your answer is, divided by 348. Go ahead, Caleb.
1/8. Are we 1.793?
1.793, so $1.79 per ingredient. What is the slope of this line? Tells me in the equation, right? Number in front of the X. 348. What does it mean? 348, what does that mean? Say that again? Yeah, so for every one ingredient, the price goes up 348. For every one ingredient, I guess $1 ingredient cost. Total cost goes up 348. So as ingredients go up, obviously your price for whatever you're making is going to go up. So for every $1 you spend on more ingredients, your price goes up 348. Obviously more than one ingredient in whatever you're making. What is the y-intercept? Well, the y-intercept is 0.76. What does this mean?
How much money they had before the sale?
Yeah, so if you buy no ingredients, if the ingredients cost nothing, you still have to pay 76 cents. Does that make sense? If you don't buy anything, should it cost you any money? I'm gonna say no. Should not cost me anything if I'm not buying anything. If I don't have any cost of ingredients, I shouldn't have to pay anything. Now, if you go to some of the stores where you gotta put money in for like a cart, in Fargo, I think Aldi does that. I see a quarter to get a cart, and then if you return your cart, you get a quarter back. Different story, but I don't know anything that would cost you 76 cents. All right,
What's the point of that?
people return their carts.
I mean,
People return their carts.
You get their card.
They have to do that.
All right, the last one, just interpreting graphs, what they mean. What does the slope mean? What does the y-intercept mean? So if you look at the first one, I'll just put a little A, B, C, D here. I'm gonna answer some of these, probably don't need to do them all. You can get the hint of it here. Top one is saying, using the horizontal, interpret the slope. So the number behind the x, this is the y-intercept. So take a look at the first one. Slope is negative 9.25. Look at what's being graphed there, and what do you think that means? Negative, of course, means it's going down. What's going down?
So we have to make like a story.
What's that?
The reaction time.
Your reaction time. So your reaction time
Oh.
goes down
How did you reach?
9.25 milliseconds for every, what? For every year. Per year older.
You mean it gets faster?
Your reaction time goes down as you get older.
Is it? What is it?
Your reaction time is going down
So that
as you
means-
get older.
What does that mean? Slower?
Slower.
What? Is it 200 milliseconds
Yeah, wouldn't
faster
it
than
be-
300?
Wouldn't it be faster? Well, I mean, it goes down, but technically it'd be faster.
Right. I see what you're saying. So we should word that differently?
No,
Well, I
that's
mean, it's fine.
Reaction time goes down
It's okay.
means we get faster?
Yeah.
Okay, I'm okay with that. Yeah, good point. At some point, that doesn't continue forever, right?
Yeah.
At some point, your reaction time is going to get worse. You know, think about grandparents at a stoplight, for instance. The reaction time is going to take a little longer. All right, what's the 400 mean? The y-intercept.
Probably when you were little, when you were just born. it was
Yeah.
400.
Newborn. 400 millisecond reaction time. Okay, how about B? Slope, 0.44.
The price of every banana.
Cost of banana. 44 cents per banana. Y-intercept would be 0.04.
No bananas, but you still have to pay for some.
Yeah, so that would be the cost of 0 bananas. Again, sometimes like that one doesn't make sense. But still ask what it means according to the graph. Jordan, you writing these down? Okay, how about C? What's the 4 mean?
Slope? Oh.
That every square foot is going to be costing you.
Yeah, remember it's rise, so it's cost to install per.
For every square foot.
Yeah, so $4 per square foot for flooring. Y-intercept,
87.
which means,
That's the cost if you don't know square.
yeah, cost of no square footage. Maybe that's how much they charge to come out before they even do any work. Fuel prices, maybe.
That's stupid.
Last one, negative 2.4.
The volume goes down for every temperature. Wait,
Yeah, volume decreases by 2.4.
for every temperature.
Volume goes down 2.4 cubic centimeters for every degree Celsius. 25, y-intercept,
25, and that's the line before
25 cubic centimeters at,
0.
yeah, before the temperature changes. At 0 degrees Celsius. To start, however you want to say that. Okay, so just being able to interpret what those graphs mean. Okay, again, what kind of plots are these called? Scatter plots. All right, there are 6 questions today, I believe, 6. That last one is multiple choice, page 53. The choices go on the next page, on to 54. So we'll go ahead and get rolling on those. Just realize that last one is multiple choice.